everyone. Today we are going to solve a question that appeared in Shift 1 on February 1, 2023. We have two reactions at equilibrium, X when produces Y plus Z at equilibrium. The Kp1 is 3 for this equation, and for the second equilibrium, that is A gives 2 moles of gaseous B, the Kp2 value is 1. The question says that if the degree of dissociation and initial concentration of both the reactants X in the gaseous state and A in the gaseous state are equal, then the ratio of the total pressure at equilibrium, that is the ratio of P1 is to P2, is equal to X in the ratio 1. The value of X is dash, and we need to round off the answer to the nearest integer possible. So let's start the solution to this question. For that, we need to first write the equation at equilibrium, that is X gas produces Y gas and Z gas at equilibrium, and for this the expression, the Kp1 value is 3. Now at initial conditions, that is at t equal to 0, first of all, for X, A moles will be available and there will be no amount of product formed at the beginning of the reaction. Then when we proceed further, few amount will be dissociated, that will be A minus alpha A, alpha X, and alpha A amount will be formed for the products. So now here it must be X over here and A over here. So now when we write the expression for Kp1, that will be equal to the partial pressure of Z multiplied by the partial pressure of Y, dividing it by the partial pressure of X. So we have the total pressure for this equals P1. Now if we substitute the respective values, it becomes alpha dividing it by 1 plus alpha into P1 whole square, further dividing it by 1 minus alpha upon 1 plus alpha into P1, that has a value equal to 3. Or on simplifying this, we can write down alpha square P1 1 minus alpha square is equal to 3. Now for the second reaction, if we proceed in the second manner, we can proceed with the next equation, that is A, which gives 2 moles of gaseous B, and the value of Kp2 for this case is equal to 1 as mentioned in the question. So when we see at t equal to 0 and at equilibrium, the initial amount will be A and 0 will be the amount of product formed. It will be A minus alpha A and 2 alpha A for the product. Now when we write the expression for Kp2, that will be equal to the pressure of B to the power square. On substituting the value, it gets as 2 alpha upon 1 plus alpha into P2 raised to the power square, dividing it by 1 minus alpha upon 1 plus alpha into P2. Or we can write it in such a manner that 1 equals 4 alpha square P2 upon 1 minus alpha square. So if we proceed with the previous expression, that as Kp1 over Kp2 is equal to P1 over 4P2, or P1 over 4P2 has a value 3:1, so the ratio of P1 is to P2 will come as 12:1. This is the final answer to the question. So that was all about this question. I hope you understood the solution. Thank you.